Well, we're figuring out what the y is.
So we want to change this equation so it looks like what, Emma? Yeah, we want y by itself. I want it to look like this. Y equals. So what do you want to go away? Do we want to pull the Caden method or non-Caden method? Caden method, non-Caden method. We're in a kind of mixing. So let's just go non-Caden method. So what do you want to get rid of? What do you wish wasn't there? Da-da-da, hands. Kirsten. Yeah. If we could just, make that go away, wouldn't it look so much more like what we want? Oh, but it's not. It's still there. How could I get rid of the 12x? What? We want all 12 x's to go away. Turn and tell a neighbor really quick. And maybe we see the point of the Caden method again. What if this was like 36 minus 4y equals 20? I'm going to pull the Caden method in the bottom right corner. What would you do to start solving that for y? What would your first step be on the green one, the bottom right corner? If your name was Jack, what would you do?
Subtract 36.
I would too, from both sides. So then let's come up to the the white problem, the original literal equation. Kirsten, what would you do? Yeah, I want to get rid of that 12x. And then I'm just going to write down what I have left. What would be left? Be careful. Rain. I can't combine x's and numbers, right? They're different things. It's like saying if I have 3 apples and 2 bananas, does that mean I have 5 apples? Does it mean I have 5 bananas? 5 apple bananas. If I have 3 apples and 2 bananas, I cannot put them together. I literally have to say 3 apples, 2 bananas. But notice, I did not catch Rain on the issue here. She brought her negative down. That's really important. A lot of students forget that. Now, we'll come down to the Caden method. So this would be negative 4y equals, and I'm just going to leave it as 20 minus 36. I'm not actually going to get the number there. I mean, I could if I wanted. What would you do next to solve for y? Ian? What's that? Yeah, on both sides, right? Notice I'm doing it to the entire side. I multiply or divide both sides by negative 4. And there we're going to get y 20 minus 12x over negative 4. That wasn't the answer that was listed, though, was it? Here we go along the side. Suppose I have 3/5 and I subtract 2/5. What does that become? Quickly. What does that become? 1/5? So you really just did 3 minus 2 all over 5? Why? Because the denominator was the same. So if I can take fractions and I can put them together when the denominator is the same, right? Could I rip them back apart? Could I take something that looks like this, 3 minus 2 over 5? Could I then say this is 3 over 5, subtract 2 over 5? I see that. I don't see that. If I can take and put fractions together that have a common denominator, I can rip them apart. Why did I make that point? look at what we have and turn and tell a neighbor, why did I just make that point? Doesn't that look like two fractions that got shoved together? Doesn't it look like I maybe had 20 over negative 4 and negative 12x over negative 4? Wouldn't those be the same thing? I can just rip them apart, put them together. Rip them apart, put it together. Because they had the same denominator? They didn't? Well, they were already put together. The question becomes, why would I rip them apart? How does ripping them apart help me? Turn and tell a neighbor really quick. How does ripping them apart help me? That's what we're proving. All right. Why rip them apart? Trevor.
So they're like their own separate problems.
They're their own separate problems. What's 20 divided by negative 4? And negative 12 divided by negative 4? Yeah, and so it's going to be 3x, right? Madison? Yes. So ultimately, I don't want anything magical to happen, right? No offense. I know you guys like your keep, change, flip. But like, some of us don't know why keep, change, flip works. It's a magical mathematical thing that you can just do. Like sprinkling fairy dust on somebody and they fly, right? How many people, be honest, you do some math stuff where you're like, this is like fairy dust. I have no clue what's going on, but you're supposed to do it. Be honest. Yeah, so I don't want that to happen, at least as little as possible, right? So when you look, that's why I'm explaining this, right? That's like two fractions that we just rip apart because they were just put together. Now, Madison, you're saying we can just, what were you saying?
I just divided 4 by 1.
You what?
I just divided 4, negative 4 by 1.
You mean you divided both numbers by negative 4? Yeah, that works. Because that divides the entire side, so it divides everything. It's dividing the entire side, so it literally divides everything.